$3,000 was invested in a savings account that pays 5% interest on January 1st, 2003. The account balance is modeled by the following equation. Please highlight, and you may share your highlighter with your partner, highlight the exact date. This is the date that we will continuously refer to. So this will be like RT. I'm going to come off to the side. It can be very small, but I'm going to come off to the side and make 3 columns. The middle column will be the smallest. The left will be years, and then this is going to describe money. It is AFT. That's off to the right-hand side. We know the initial year and date is January 1st, 2003. That's T equals 0. So if I said T equals 1, it'd be January 1st, 2004. If I said T equals 2, it'd be January 1st, 2005. Again, if it was a 3, January 1st, 2006, and so on. Okay, so the first thing we're going to do is please clear your calculator like I have done. Second plus 712. RAM cleared. And now we're going to plug this in together. We're going up to Y equals, taking 3,000 times 2 raised to the 0.05. And although it has a T on our calculator, we are going to put an X. Do not hit graph yet. When you are done, please go to the windows, and we're going to adjust the windows so that we can all look within the same range. So please go to Windows. I'm going to look through these questions first of all, and I'm going to highlight what I need to know here. So I'm going to go down. Yes, we're going to come back to graphing and sketching the graph, but let's go down to part B. I'm given this date, and I actually want you to box in what we're trying to find. How much? Our T value, or on the calculator, the X value is going to be in terms of years. So X is in terms of years. It's T over here, but remember when we plug it into the calculator, it's going to be X. And our Y value, or A of T, is going to be the amount of money. So when it says how much, they're referring to the Y value. This is going to be a Y answer. Again, they give us part C, gives us another date, and it says how much. I'm going to box in what I'm trying to find and highlight any other important information. How much refers to how much money. That's a Y value. Part D says what year. Time is an X. Time is an X. So in this case, we want to know in what year. Now, not only that, we want to know how many additional days there are. How many additional days are there? So for this problem, this is kind of unique. So for part D, we are going to have 3 different answers. The first will be in what year. This is going to be a year. The second part, the second question in part D will be years and days. Okay, let's get started. So we have our graph, and I'm looking at the information that I'm going to have to answer. And I'm specifically looking at what year do I need to go out to. So I'm going to have January 2000, January 1st, 2010. I'm going to have to do April 1st, 2015. And so what I'm wondering is how far am I going to have to go out for a T value? Well, as a reminder, how do we determine the T? We are going to take the year and subtract it. So this is going to be a year 7. This is going to be a year 12, plus there's this additional time that we'll talk about later. So I know I have to go to at least 12. Again, why? This is our initial year. This is a difference of 7. This is a difference of 12. So when I come here, I know X represents years. So in the X's, I'm not going to have negative years, and I want to go up to at least 12. Let's go all the way up to 15. We can adjust it and make it higher if we need to. Now hit graph, and we see nothing. So at this point, we're going to hit zoom fit. You can hit zoom 0 or go all the way down to zoom fit, pressing enter. All right, I need to know January 1st, 2010. Here's the easy part. We're going from January 1st to January 1st. So it's the exact point of the year, and we increased by 7. So my T is exactly 7. There's no more additional days. So for that reason, I can come up here, and I get to go second trace and go to value and type in 7. Please do the following. Okay, the next thing that we're going to do here, the very next thing is we're going to round this to the nearest cent. Round to the nearest cent. Please do that. So I have an answer of $38,023.68. This is my answer for part B. Now, part C, again, how much? I'm looking in the Y. Now, when I count here, here's the confusing part. The easy part is to go from 2003 to 2015 is a total of 12 years. So the T value is 12, but then we have this additional time. Notice it's not January 1st, it's April 1st. And it tells us that April 1st is the 91st day in the year. So in addition to this, I need to go 91 over how many days are there in a year? 365. So on our calculator, we're going to go second trace value. Typing in 12, that's the change in years. Plus we have additional days because it's not January 1st. We have in parentheses 91 divided by the number of days in a year. And now please round this to the nearest cent. So this is going to be $4,586.61. Before we go on to part D, I'd like you to flip your papers over to the back and write number 1. And these 4 problems, we are all going to go back to this original. We're all going back to January 1st, 2003. So I'm just going to put that down here, January 1st, 2003. Please don't talk when I'm talking. So we want to know how much, and then we're given a specific date. So how much is referring to money. And so the first thing I do is I flip over to the front and I go, okay, when we're talking about how much, we're talking about money. So each one of these, I want to know a Y value. So when I'm looking at the calculator and I'm using the different keys, I'm looking for a final answer that's within the Y. Okay, so I have my graph, and now I have to ask myself, from 2003 to 2011, how much time has passed? There's nothing wrong with counting on your fingers, or you can grab your graphing calculator and just subtract. 2011, subtract 2003 is a difference of 8. So I know my T value is 8, but remember when we go to a calculator, T's turn into X's. But I have this additional time. So how much more time? 120 over 365. I grab a calculator, second trace value, and I do 8 plus 120 divided by 365. Okay, and I'm going to take the Y value and round it to the nearest cent. So $4,003.89. $4,003.89. Why I think part 2, number 2 of these practice problems is easier than number 1, 3, or 4 is as long as it lands on January 1st, I don't have to worry about this extra. As long as it lands on the same day of the year as our original date is given to us up here, I don't have to add the additional time. So I'm just asking myself, what's the difference from 2008 to 2003? That's a difference of 5. So I grab a graphing calculator, second trace value, I type in 5, I round it to the nearest cents, I get 35.67.62. 35.67.62. So to go through this, I'm asking myself from 2003 to 2010, that's a difference of 7. You can subtract them on a calculator if you're not great with mental math. But there's this additional time because it's not January 1st, and I tell you how many additional days there are, 73 additional days. Now, how do I know to put over 365? Ask yourself, how many days are there in a year? I grab the calculator, second trace value, 7 plus, and then in parentheses, 73 divided by 365. This is my answer, 38.50 and 28. 38.50 and 28 if we round it to the nearest cents. My very last one, again, how much? I'm looking for a Y value. Now, it tells me that April 2nd is a 101 days in. What's the difference from 2003 to 2008? That's a difference of, anybody? 15. Plus we have these additional leftover days. 101. So I grab a calculator, second trace value, 15 plus 101 divided by 365. And I'm going to guess, did I write something down wrong? Oh, thank you. I'm going to guess that it's going to say error because I'm guessing I haven't pushed out the calculator far enough. Let's check. It says error. So I come back up here and we can see I only went to 15. I have to go beyond 15 because it's a little bit more than 15. So anything more than 15 will work. Let's try this again. If you get invalid, it means you probably need to adjust your window. Second trace value, I have 15 plus 101 divided by 365, and this rounds to 5093. Oh, okay, now this is a great one to review. I'm going to round to the nearest cents. The 7 pushes the 9 up, and this not only becomes 99, it bumps up to 1. So this is going to be $5,094 if we round to the nearest cents. $5,094. Last one here is if I asked again how much, so I'm going to get a Y value. And last one to practice here is January 10th, 2004. So I'm only going up 1 year, so my T value is 1, but I have these additional days, 9 additional days, 9 over 365. Grabbing a calculator, second trace value. I have 1 additional year, and then 9 divided by 365 gives us a value, kids are practicing here in the classroom, a Y value of $3,108.45. Flip back to the front, please, and let's look at, in Part D, it tells us in what year will we reach 5,000. So they're giving us a money amount. They're giving us a Y, and we want to determine the X. Anytime they provide you a Y, you're going to go up to Y equals. Now grab your calculator and go to Y equals, and do not clear out the first equation. Go to the second part that is open, and we're going to type in the amount of money that they provide us. We want to know in what year will we reach 5,000? Now, 5,000 is the Y value. I don't even know if my graphing calculator goes up to 5,000 right now. Let's go to Windows and check. Okay, it does go. It does go past 5,000. So we should be able to see this. Go to Graph. And I'm going to use the keys on the calculator to find the precise intersection point. Second, trace, intersect. And the nice part is when there's only 2 curves, I can just press Enter, Enter, Enter. All right, I want you to find this, and I want you to write it down off to the side. So X equals 14 point, do not round, write down the exact amount. We will be able to answer our questions based on this exact amount. So remember that X's are like T's, and T's represent years. So we have 14 full years. So in this place, please write 14 years. And now we have this additional amount. It's getting close to 15. It's not quite there. So I'm going to put in the decimal amount, 0.739312. And the question a lot of students ask is, what do I multiply by? How many days are there in a year? We're going to round to the nearest whole number. So we're going to round this up to 270. Now, how does that help me answer in what year do we hit 5,000? In what year do we hit 5,000? Well, we have to go 14 more years. So great, those that are great with mental math, you're going to add 14. If not, you take this initial year and add 14 to it. So 2003 plus 14 bumps us up to in the year 2017. Do the exact same thing, but we are going to practice. So grab your highlighter if you're sharing here. And if you don't want to write this all out, that's okay. But in what year? So what year? That's what I'm trying to find out, and I'm provided this. In what year? What I'm boxing in tells me what variable I need to find. So in what year means an X value. I'm trying to find an X value. Okay, so I'm going to start with the first one. Let's go with 6,000. I'm going to start with 6,000. So I'm going to go back here, and I'm going to change this to 6,000, and then I'm going to go to Windows. I'm going to change this to 6,000. I'm going to go to Windows. Right now, would I even see 6,000? No. So I'm going to go past this, and I'm going to go up to maybe 8,000. Just something past 6,000. I still need to adjust again. Let's see. So here's the original function. And if this was an iPhone, it'd be awesome if I could just push this out. It'd be great if we could do that on the screen. So I need to take the X's and push it out. So go to Windows, and we want to push it out here. Let's try going out to 20. It may not work. Can I still, it's almost there. Do you guys agree? I think I'm just hitting it right now. If you want to go a little further so you can definitely see it, feel free to do so. I just pushed it out to 22 so everybody could definitely see this point. So I went, if you're a little behind, I went from 0 to 22, and I made sure that my Y window shows everything. Now I'm going to go second trace, intersect, and I'm going to find that exact intersection point. And I'm going to write it down off to the side. Oh, that was a nice number, 20. Exact. It was exact number 20. So this represents the number of years. So I get to put a 20 here. There's no additional days. There's no decimal. It's perfect. But now I need to fill this in. Who remembers what was the initial year here? It was January 1st, 2003. So January 1st, 2003 was this initial year. So if I get a year of 20, then what goes in here? In what year did you reach 6,000? It would be 2020. All right, so for part 7, I'm changing the 6,000 from the previous problem to 4,000. I'm graphing it. And I'm going to identify the exact point at which these two lines are going to intersect. I write it down off to the side. So there is exactly 8 years, and then this additional time I need to turn into days. So I take 0.30075 times, how many days are there in a year? 365, and we're going to round to the nearest whole number, which is 110. All of that's great, but now what does that mean in terms of the year in which this happened? We started at 2003. If I add 8 to 2003, I'd be left with 2011. Let's do one more now. I'm going to switch here to 35. So I come up here. I'm going to switch this to 3,500. Graph it. I'm going to do the exact same thing. Let's find where they intersect. When there's only 2 curves, I can just press enter 3 times. 1, 2, and 3. And I'm going to write down this number. X equals 4.4478484. What does that mean? That means there is exactly 4 years, and then this additional part, 0.4478484. Whoop, I made some mistakes there. 0.4478484. I'm going to take that times 365 because there are 365 days in a year. And we'll round this to the nearest whole number, making it 163. In what year can we expect the amount in this savings account to reach 3,500? 4 plus 2003 would be the year 2007. Didn't do that I should have done is I should have filled in, this is a very easy part to do. I'm going to come back here at the very beginning. I should have filled in what this graph looks like. So I go up to Windows. I'm going from 0 to 22 here. Now we could have done this at the beginning and gone from like 0 to 15. I'm going to write down I'm going from 3,000 up to 8,000, whatever's on my calculator. I'm going to graph it, and I'm just going to draw the picture of this. So it's looking like this. And now we have completed number 1. We're going to look at number 2 next. How we type this into the calculator matters. University of Phoenix Stadium, now known as, isn't it called State Farm Stadium? It opens the gates at 9 a.m. So there's going to be an event there that day. Let's highlight what happens. At 9 a.m., the gates open. The attendance within the stadium can be modeled by this following equation. I want you to come over here. Let's talk about what each of these means. H represents the number of hours that the stadium is open. And A of H represents the population at any given point in time. So we could say after 1 hour, how many people are in the stadium? After all. Okay, next we're going to come up here. We're going to go to Y equals. And now this is tricky. This is tricky. When you plug this in, we're going to put the numerator and the denominator in parentheses. So I'm going to put 70,000. Yes, that's 4 zeros. Divided by, we're going to start another set of parentheses. 1 plus 5931 times 3 raised to the negative 3.7. Now we don't have an h. We will use an x. I'll use the arrow to bring it back down and make a parenthesis, please. Now, everybody go to Windows. Our x's, our h is up above. So the stadium is open for 8 hours. So we only are going to look at the attendance over the 8 hours that it's open. So go from 0 to 8. And when we graph it, we're not going to see anything. We need to hit zoom. And again, you can hit zoom 0 or scroll all the way down to zoom fit. It'll achieve the same thing. Go through this, and using that highlighter, we're going to highlight main information. We're going to box in what we're trying to find. So, how many fans? And then we're given a specific period of time. So we're going to be given a time, which is like an H, or it converts to an X in the calculator. We want to know the number of fans. That's the population. So we want to know what is going to be a Y answer. Same thing for part C. How many fans? We want to know a Y, and we're given a particular time. And lastly, we want to know what time. So we want to know time is in terms of hours. What time did the attendance reach a particular point? So for this one, we're going to leave this. This is going to be time. So this is like for instance, right now it's 11:54, right? You get out of here at around 12:36. That's how we're going to fill this in. Let's start back up here right now with 12 o'clock. My T sub 0 is right here. So I'm going to make myself just a really small table. This is my T's, and this is in terms of time. So not a date, but time. And this is going to be my attendance. So I should say H. I should say H, not T. And this is A of H. So my initial one, H of 0, is 9 o'clock. 12 o'clock means noon. How much time has surpassed when you get to noon? From 9 a.m. to noon is a total of 3 hours. So I'm going to plug in H is going to be 3, or think of it as T is going to be 3. So let's come up here and go second trace value. We're going to type in 3, and we're going to round to the nearest whole number. So taking this value that I'm going to zoom in on, please round to the nearest whole number. 67,961. All right, let's go on. Now here's where it gets a little tricky. When I'm looking at part C, how much time has surpassed when you get to 1 p.m.? Okay, there's 4 hours, so that's the whole number, 4 hours, but we have this additional minutes. And so oftentimes students go, what goes on the bottom? How many minutes are there in an hour? Okay, so this is going to be 4 plus 5 over 60. Again, here we go. 4 plus 5 divided by 60 using those parentheses. And we're going to round to the nearest whole number. 69974. I would like you to flip to the back if you don't have room. Take out an addition. So I need to figure out real quick, what is my H, or I called it T in the last problem. What's my T value? Well, from 9 to 1 is a difference of 4. 9, 10, 11, 12, 1. So I have 4 full hours, but there's additional time. There's additional time from 0, 0. 45 more minutes. How many minutes are an hour? 60. So I'm taking my calculator, I'm coming up here, second trace, value 4 plus 45 divided by 60, and I'm rounding this to the nearest whole number, 69,998. Let's do the next one. How many fans will be there at 10:35? Again, from 9 o'clock to 10:35 is 1 hour, plus we have these additional minutes over 60. Second trace value, I have 1 plus 35 divided by 60. And if I'm going to round here to the nearest whole number, I'd have 6,660. Up here, this was complicated for kids. We now want to know what time. Time is our X, or in this case, our H value. So I want to know an X value, and I'm given population, which is a Y value. So come up to your graphing calculator, go to the second line and type in 40,000. Now I'm going to go to Windows, and I can see that 40,000 will fit between 11 and 70,000. So I graph it. And I want to know exactly where does it cross. Second, trace, intersect. And I'm going to write this time down off to the side. So I'm going to write down the exact time. I'm going to do no rounding. 2.2081002. How do I convert this? This represents time in hours. So there's 2 full hours. Then I take that decimal amount, and I'm going to type it in, it was 2081002. And I ask myself, how many minutes are there in an hour? There's 60. And I'm going to write this down, 12.48. Now, I need to take this. This means from when the gate opens at 9 o'clock, if from that point we had a stopwatch and we went 2 hours, and let's just round this to 12 minutes, okay? If we went 12 minutes, 2 hours and 12 minutes past this point, we can assume that the attendance would now have reached 40,000. So how do I do that? If we're at 9 and I add 2 hours, I'm going to be at 11 with 12 minutes. So at 11:12, we can assume the population reaches 40,000. Flip your paper to this problem. We are now going to practice just like we did for the last one. So instead of doing in what time did the attendance reach 40,000, now I'm asking at what time did the attendance reach 25,500. So I'm going up to y equals. I'm changing this to 25,500. I'm graphing it. And then I'm going to find that intersection point. So here's my intersection. Second trace, please no talking. And I'm going to write down this exact intersection point. The exact intersection point is 2.000346. By raise of hands, who came up with this before I move any further? Now, what does this mean? Well, this is hours. So there's 2 hours. Please no talking. I'm going to take this additional part, 0.000346, and I'm going to take it times how many minutes there are in an hour. And I'm going to round it to the nearest whole number. Well, if you round this to the nearest whole number, do you agree it's just 0? Okay, so exactly 2 hours, we can assume this would be what we have. Well, what time did the doors open? So if I add 2 hours, what am I at? 11 a.m. Number 3, the population of Vice City from 1995 to 2003 is given by the following table. So we're going to plug this into the graphing calculator. How do we do that? We're going to go to Stat, and we're going to go to Edit, and here's the key. Time, years, is always your X. So in the L1 column, please put 0 through 8. Go back to L2, and we're going to put in the corresponding population. Then go back and make sure that you correctly type this in. When I hurry, it is very often I find myself making small mistakes. So let's go back and check. So this is the population in millions given the following year. So this is 95, 96, 97, 98, 99, 2000, and so on. Okay? Once I have this, can everybody please go to Stat, go to Calculate, and then we need to create a cubic model. So we are going to go right now to all the way down to number 6. Go all the way down to number 6 and press Enter, and continue to press Enter until you come up with the following data. When you and your partner both have this, please put a red cup on top. Okay, so we need to turn on, so we see all those little dots. So we're going to do three buttons. We're going to start to do second, stat plot. So second, y equals, and on. Second, y equals, and turn it on. If you're wondering what I just did again, I'll come back here. We did second. Once we had this, we did second, plot on, and make sure that you've turned it on. So sometimes you have to press Enter. Make sure that's highlighted. Then go to y equals, please. There's no equation there. We haven't copied and pasted what we just did. Please hit VARS on your calculator. Go down to statistics, which is number 5. scroll across to EQ, and press enter. We just copied and pasted in the equation. Give me a green cup when you and your partner have this. I see many more people that do not have green, so I'm going to come back here. Okay, please watch. We put in the data. And then it's going to tell you. It's going to tell you exactly what you have to create. A cubic model. So how do I create that? I go to Stat and Calculate, and I find the one that says Cubic Regression. It's a cubic model. And then I just keep pressing Enter. That's it, okay? Now, how do I copy and paste this into y equals? I'm going to clear this so you can watch me do it. I hit vars. I go down to number 5, cross to EQ, press Enter, and it copy and paste it in. Okay, let's take graph. So all of this is beautiful, but I haven't set up the correct windows. The window here goes from an x value of 0 to 8. Let's go a little further. Let's go like 0 to 15. Let's go 0 to 15, please. 0 to 15. And we can even make it, let's actually make it a little smaller, just so we can see everything. We can always go back and change it. So let's go 0 to 12. Now we need to make sure that the range of the y's adjusts to what we have for the x's. So let's go zoom, fit. So zoom and all the way down to zoom fit and hit graph. If you and your partner have this, please give me a red cup. Now how do I adjust this to this window? I wrote down exactly what I have. 0 to 12. 0 to 12 and 1.3 to 14.8, and then I just draw the picture. Please do the following. So I'm looking at part C. I want to know how high is the population. So what is the population before the drop-off? So I want to know population. Population is a Y. Let's look at this graph. So we can see here's the drop-off. Does everybody see the drop-off? We want to know how high did it get before it started to drop off. That means what is this maximum value? How do you find maximums? Second trace maximum. And I want you to take this little cursor and I want you to move it to the very top of this hill. And then follow the directions. Go left bound. So go anywhere to the left, press enter. Go anywhere to the right of the highest point, press enter. And now we go to the top of that hill, and let's see if you got the same that I did. Now it says how high. We want to know the y value. If you simply write 2.53, you're going to be wrong. Come back up here. What does y value have to be in terms of? All that means is take that decimal and go 6 places to the right. So I'm going to do this slowly for anybody that's confused. 2.53685519. That's what we have. And now millions means 6 zeros. So I'm going to go 1, 2, 3, 4, 5, 6. Does this tell me to round up or stay the same? That's an ugly 9. Round up. So I have 2536852. This is the population before the drop-off. Okay, the next part is, again, is a population question. How low did the population get before it rejuvenated? Rejuvenated means it's beginning to grow. It's beginning to grow. And we can see here's the growth. It says how low does it get before it begins to grow? I want to know what is this low spot. The low spot is known as a minimum. Second trace minimum. Use that arrow again to go to the very lowest point. And then follow the directions. Go to the left, enter, go to the right, enter, and back to the lowest point. See if you can come up with the same answer that I did. Again, we're trying to find a y value because it's population that I'm trying to identify. Population, okay? So I'm going to come over here and write this down. Population is 1.304184. So once I found the minimum value and I identified the population, again, you may be wondering, how do I know if I focus on the X or the Y? That's why we're boxing things in. I want to know population. I want to know Y. I want to know population. I want to know Y. Now I need to turn it into millions. 1, 2, 3, 4, 5, 6. This says don't round up. I can just cross that off. There's our answer. Lastly, according to the model, what was the population in 2002? Well, the first thing we need to do is ask ourselves in 1995 was 0, then 96 was 1, 97 is 2, 98, 99, and the year 2000 was a 5. That's going to be a 5 for us, okay, in terms of a t-value. So when I think about the year 2002, the year 2002 is a 7. How else could you get that? You take what year we're trying to identify and subtract it from the initial year. So 7 is what I want. Let's go second trace, value at 7. This is our population. Let's write it down again. 1.4417677. I'm going to move the decimal how many times? 6 times. 1, 2, 3, 4, 5, 6. Yes, this says bump up. So 1441768. This would be my final answer.